Good morning students, welcome to the session on data structures. In our previous lecture, we have started our variants of recursion. In that we have seen two types of recursions, one is direct recursion and second one is indirect recursion. In our today's session, we are going to see binary recursion and the second one is tail recursion. Okay, see what do you mean by the binary recursion is whenever a function call is made, then that function call in turn it invokes one more function. But here in our recursion case, we are calling our same function within the same function. Say suppose if you are having a function called Fibonacci, then within this Fibonacci series function I am having one more call for Fibonacci only. Okay, we will discuss what is Fibonacci, but see here, whenever a function call itself is called as a recursive function, but when a function call itself for two terms within the function, then it is called as binary recursion. It is the simple definition. Whenever a function calling itself, but it is making two times, it is making two function calls within a function, then it is called as binary recursion. The simplest example that we can have is your Fibonacci series program. Okay, already you people know about the Fibonacci series. If you don't know, the Fibonacci series will form as like this. Say suppose if I am having some numbers 1 and 1, then the Fibonacci series will be given like this. 1 will gives us 2, and 2 plus 1 will gives us 3, and 2 plus 3 is gives us 5. Okay, like this we will be having the series. Okay, say suppose if I want to find the Fibonacci series until 5, then I will be using this binary recursion. Say suppose my n is 5, then I will be making a function call. If it is 1 and 2, then return what? 1, else return Fibo of n minus 1 and n minus 2. Consider my input is some 5, Fibo of 5. Then we will be using the stack in order to execute this, but we are calling function for two times. Okay, when the function call is made, then I will be checking the condition. If the condition is true, then I will be returning 1, else I will go for return part. Okay, then here you see my n is not 1, my n is not 2. Then I will be making a function call like Fib of n minus 1, that is 4, and then plus Fib of n minus 2, that is 3. Okay, like this I will be making a function call. Actually, I will be calling this function, and in turn I will be checking this condition, and if it is not possible, then I will be making these two calls. Say suppose I will be dividing them Fib 4 and Fib 3, and in order to do that, we will be having some addition. Then when I am going for this, again in turn it will be making two function calls, Fib of 3 and Fib of 2. Okay, n minus 1 and n minus 2, and I will be adding that result, and Fib 3 will be again calling the function for two times, Fib of 2 and Fib of 1. Okay, no, in turn it will be making a function call, but see, whenever we are sending value as 2 or 1, it will be returning as 1. It won't make any function call. It will be resulting as 1, and it will also resulting as 1. Then we are adding these two by using this function, and we are returning it to Fib 3. Then the result will be 2 here. Our Fib of 2 will give us what? 1. If n is equals to 2, then I will be returning what? 1. Then this will be returned here. Okay, first I will be printing this 1 and 1, and I am printing what? Just I will be printing 1 again for the first time, and 1 again for the second time, and when I am going for this Fib of 3, then it will be printing what? 2. And after printing this, we are making a function call of Fib 4, then 2 plus 1 will be given as 3, and this will be printed on the screen, and in turn Fib 3 will give us what? 2 as result, as we can see here. Okay, and this 2 and 3 will give us a 5. Then our Fibonacci series will be like this. Here you need to understand what is binary recursion. A binary recursion function call is a function where within a function it will make two function calls. Within a function it will make two function calls in order to complete its task. Okay. The example is your Fibonacci series function. Like this, we will be executing our binary recursion in order to get our Fibonacci series. I hope it is clear to you people. Fibonacci series is not a concept of your data structure. You people might have studied in case of C language and C++. Okay. See, Fibonacci series is a series. By adding the previous two numbers, we will be getting one more number, like that we will be getting. Okay, say suppose 1 and 1. Say suppose even if you are starting from 0 and 1, 0 and 1 will give us 1, 1 and 1 will give us 2, and 1 and 2 will give us 3. Like this, we will be having the Fibonacci series. In order to find that, we will be using this binary recursion. Okay, this is how we will be using our binary recursion. And see, here we are having the second part as our tail recursion. What do you mean by tail? Tail is an end point, I can say. Okay, tail is an end point. Whenever you are speaking about something, see the tail. When you are saying about the tail will be the end point of something. Say suppose if you are taking any end point, then I will be talking the end point as tail. Okay, whenever I am executing my function, whenever I am making a recursive function call, then that should be the last function that I am going to do. You need not to have, or else you should not have any remaining part to execute in your function. Then it is called as your tail recursion. For example, if I am executing this function, my function call, whatever the recursive function call that I made, that will become the last step for my tail recursion. How you see? See, if I am executing this, see in the main function I am calling a function called function, and within the function I am making a function called function n-1. Say suppose here I am setting 3. Okay, then if it is equals to 0, then I will be stopping the program, but it is not equals to 0, then I am printing n here. Okay, I am printing 3 and I am returning, and I am executing return function. Return what? Fun of n-1, that is here 2. Here n will become 2 here. After this function execution, I am not having anything to execute. Okay, no need of any evaluation, I can say. Say in case of your factorial function, in the last step I have written like this one: return n into fact of n-1. See, when I am executing this, after execution of this I need to evaluate this function, but here in this case I am not evaluating anything, just I am making a function call. That is the reason it is called as the tail recursion. You should not have any evaluation process after the function call, so that particular recursive function is called as tail recursion. Okay, I hope it is clear to you people. In a factorial function, I am having an evaluation call n into factorial of something. But here in this case, I am not having any evaluation. The last step is the step where I am making my function call. I am not having any evaluation part over there. Okay, then see, after this I will be calling the function, again it will be printing 2, and then I will be calling the function, again it will be printing 1, and again it will become 0. When it is 0, I will be returning nothing. And after the function call of last one, we are not having anything to evaluate, then it is called as tail recursion. This can be implemented by using stack. This can also be implemented by using stack. Direct and indirect can also be implemented by using stack. For example, if I am executing this by using the stack, then already I told you people, in a recursive I will be inserting our functions onto the stack. The main function will be inserted first, and I will be making a function call with fun of 3, then that will be inserted. Okay, and it will be printing 3 When I am calling this fun3, I am not having any rest of the part to execute. Just I am executing fun2 now. Fun2 will be inserted onto your stack, and fun1 will be inserted onto stack, and then fun0. Fun0 will return nothing, then it will be popped out. Fun1 will be popped out, fun2 will be popped out, fun3 will be popped out. we are not having anything to evaluate. Say suppose if I am having n into factorial of something, then I need to pop out this and I need to multiply with that particular number. But we are not having anything like that, just we are popping out the functions after reaching n is equals to 0. That is the reason we are calling this as tail recursion, and this function is called as binary recursion when it is making two calls within a function. Okay, when we are calling a function within that particular function, if you are calling it for 2 times, then it is called as binary recursive function, I can say. Okay, this is how we will be using different kind of variants of your recursions, I can say. These are very important in order to understand the concepts which are related to your recursion. I hope it is clear. It is a very simple topic. Okay, I hope it will be clear to you people. Okay, I will place the related notes onto your group. Just go through it. Thank you. See you in the next one.